Excellent. Hannes, can we share the screen, please? Let's kick this off. Great. Well, a very warm welcome to all our guests this morning. Thank you for attending the third session of our webinar series. My name is Russell Schultz. I'm from the Process Automation Department. And for those of you who have been following us, we have conducted 2 sessions prior to this. Understandably, in process automation, we believe that process automation solutions are just that, they're solutions. In other words, there are multiple components or facets to it. So the very first session we spoke about, we dealt with the basics of process valves. We looked into things like diaphragm valves and ball valves and knife gate valves, and looked at it from a pure mechanical perspective. So if the media is in contact with the process valve, what do we need to take a look at? And then the second session dealt with the sizing of actuators for butterfly valves and ball valves. Commonly, people take a bit of a stab at this and take a bit of a thumb suck. So we took a look at how to size ball valve and actuator, well, actuators for ball valves and butterfly valves from first principles, and using software sizing tools. So that was the second session. The third session is today, of course, and that's to do with basic pneumatics for process automation. So we all know that there is control behind process automation solutions, and today we'll be discussing that. A bit of background: this is a joint venture between AVK and Festo. The simple philosophy behind this interaction is that we believe that we need to look holistically at a process automation solution. AVK being the specialist in process valves and Festo, of course, being a specialist in automation. It's a logical conclusion to how we want to address this topic to the audience itself. Also, I'd like to point out today that the session today is just a teaser. So behind the scenes, Festo has been developing a process automation course, specifically focusing on pneumatics of process automation. And Hannes, my co-presenter, will be discussing that today in more detail. But please just recognize this is a teaser, isn't a full-blown course. He'll provide more details about what is available from Festo shortly. So just a quick welcome note, introduction to my co-facilitators. I'm joined in the background by Rolf. Rolf is from AVK. He'll be assisting with the questions you might be posing in the background. Hannes will again explain to you how to do that. So any questions that may or may not relate to today's topic, we can look at and answer for you in the background. And of course, we'll open up a chat session towards the end so you can ask questions directly. And then Hannes heads up the didactic training division for Festo. So he's more than able to present today's training. I'm actually looking forward to his presentation. And that pretty much comes to the end of my welcome and introduction to you. I just thought I'd take one quick minute out to explain to you that this is an informal, relaxed session. And on the topic itself, the very first session we began with, I tried to provide a very poor joke about Chuck Norris, and saying that Chuck Norris is in the thick of things when it comes to coronavirus. I certainly hope that you all are well and aren't exposed or haven't been succumbed to the coronavirus. But I'd just like to know, as a positive note, Chuck Norris was positively identified as having coronavirus, but since then the coronavirus has been put into quarantine. So we must know that Chuck is in the fight and is certainly sorting the coronavirus out for us. But without further ado, I'd like now to hand you over to my colleague, who will then take you through the formal training today. Over to you, Hannes. Thank you very much.
Thank you very much, Russell. Just an indication, can everybody hear me good?
Sounds good, Hannes.
Fantastic. So welcome from my side as well to everybody attending this course or this webinar. We are going to take a quick look at some of the most important aspects when it comes to the pneumatic control for process automation. We are in the process, as Russell mentioned, of developing a process automation course, specifically around the needs of process automation customers with topics like process valves and actuator sizing and selection, and a lot of hands-on applications. So we will send you communication on the details of the course, and I really hope to see all of you there as well. But getting back to today, I invite you to please take part in this short webinar, engage all you can and make it a value-adding hour. There will be, as Russell also mentioned, an opportunity for questions at the end of the webinar. So please make a note of any questions you have during the webinar. Okay, so just to go through the content quickly, we will be having a look at the following topics. Air preparation for pneumatic applications, actuators for process valves, symbols and labeling of pneumatic equipment, speed regulation. So let's start with a very important topic of air preparation. As Russell also mentioned, this is just a teaser. It's a lot of content and there's so much we would like to speak to you about, but we've only got so much time. So we're going to go through everything quite quickly, but you're more than welcome, as we mentioned, to ask questions at the end of the webinar. Okay, so if we look at the compressed air generation system, that is where the first stage of compressed air preparation takes place. The system is made up of various components in order to get relatively clean, dry, compressed air. Now, you will see there, first of all, you've got a compressor, and then you've got your cooler. As the air is being compressed, it heats up. And when the air heats up, free water evaporates, and the humidity of the air becomes very high. But if the air is not cooled down after the compressor, the water vapor will condensate later in the line when the air does cool down, which will result in a lot of water problems at your applications. So we will see later on exactly how important it is to get that air cooled down as quickly as possible. Number 3 is the condensate separator. Number 4 is the receiver. Now the receiver has got more than one function in the generation process. So firstly, it acts as an accumulator for the compressed air, but it also filters out any fluctuations of air pressure that could be coming from the compressor switching on and off, or then air usage from the plant. And thirdly, the air is given more time to cool down and the vapor can condensate further. Number 5, we've got the condensate drain. Number 6, pre-filter. Now, generally, this is a filter to filter bigger particles like pieces of rust that might be coming from the receiver, just to protect the equipment down the line. Number 7 is a dryer, which also cools down the air even further to ensure that as much as possible vapor condensate. Then number 8, we've got our electronic purger. Number 9 is a series of air filters that increase the rate of filtration. So by the time the air has left number 11 or the third filter, and all the equipment is working in the generation process, the air should be clean and dry for use. However, we all know that the dryer or one of more of the filters are normally bypassed and in maintenance, and therefore it seldom happens that the air is at the high standard when it leaves the air generation plant. So therefore we need to take care of that later on in this distribution process as well. And then number 12 is the water and oil separator. Next, we will have a look at the different components of our service units and air preparation components closer to the application itself. I would like to point out the difference between plant air and instrument air. Generally, plant air is for machines that require air that does not have to be extremely clean or dry, and usually require large volumes of air, which is correct in a certain way. And instrument air, on the other hand, needs to be clean and dry and oil-free for pneumatic instrumentation. However, the better quality your plant air can be, the better for your equipment, your systems, and your processes. It's always a play-off between an initial investment in a proper air preparation system or continuous and often unforeseen expenses on breakdowns of equipment due to poor air quality. Now, why is it important to have clean and good quality air? Believe it or not, but the one aspect in your factory that you can control to a certain degree could be the machine uptime and availability. The air preparation installation is the lungs of your setup. And remember, the body can only be as healthy as the lungs. That being said, a relatively small investment in air preparation equipment helps to prevent faults in pneumatic systems, increases the life of machines and components, and increases process reliability. Now, in order to keep your compressed air system healthy, we need to get rid of particles such as dust, rust, and other solids. We need to get rid of water that is naturally part of the air around us in the form of humidity. And we need to get rid of oil, which is coming from pollutants in the air, as well as from compressor oils. Please note that these oils are not good for lubrication in the pneumatic systems and can lead to premature breakdown of components. If you look at 1 cubic meter of air, it can contain up to 100 million dust particles, 50 grams of water, 0.03 milligrams of oil, and various other chemicals suspended in the air. Now, the following slides are a few examples of what happens with your equipment due to poor air quality. Here we can see badly worn seals due to dirt particles in the air. And if I'm talking about air, it's the compressed air in your system, obviously. This is an example of a filter element malfunction. Because the filters were blocked, they failed completely and a lot of dirt and oil got into the equipment and instruments with very expensive consequences. Now, if we compare that with the cost of a new filter element, this is just turns out to be gross negligence. This is sludge buildup in the filter bowls. And this is how the valve body on the inside looks like when dirt particles accumulated where the spool and seals are moving. So certainly a recipe for early malfunction of your valve. Now, if you have any filter elements in your plant that look like this, please get into contact with any of our sales engineers or consultant as soon as possible, because it really is only a matter of time before it will cost you a lot of money and time. So let's have a look at the components that could make up a service unit. Firstly, we have the filter unit to filter out dust and condensation. Then we have our regulator to regulate line pressure. Then we've got our lubricators after the filter units. And this would then make up a simple service unit. You will note that the filter and the regulator can be incorporated into one component, as you can see in the picture over there. If you look a bit closer at the filter units comes in different grades of filtration for different applications. It's important to gradually increase the grade of filtration from a lower grade, like a 40 micron, to the desired grade of filtration to prevent premature blockage of your more expensive fine and micro filters. Now, the working principle of a pre-filter is specifically to remove solid particles up to a certain size, depending on the filtration, for example, 40 or 5 micron. The other main function of the filter unit is to get rid of fluids like water and oil that is present in the air line. Now, due to the structure of the baffle, I hope you can see my pointer on the screen. Due to the structure of the baffle, the incoming air is directed in a circular direction inside the bowl. And because of the speed of the air, the condensate is separate from the pressurized air as a result of the centrifugal force, and it accumulates then at the bottom of the filter bowl, as you can see there. The dry air then moves from the outside of the filter element inward through the filter element where particles are filtered out of the air, and only after that final filtration does the clean air leave the filter unit. The correct sizing is always also quite critical. One thinks that I'm going to go as big as possible, but that is not really the case, especially for your water separation applications. So first of all, if the service unit is too small, it will cause an unnecessary restriction in the airflow. But if it is too big, the speed of the air through the unit will not be high enough, and there will not be enough centrifugal force, as I explained, that will be generated for the condensate to be removed. Now, as you can see, there's a very specific flow rate for each size filter. You can see there's 0 to 2,000 liters per minute, 5,000, 15,000, 28,000. All right, it is worthwhile to calculate your air consumption before the time to obtain the correct size of air service unit. By default, there are 2 drain options available, namely the automatic drain and the manual drain. Automatic drain you can see on top there, that's the symbol for the automatic drain, and the manual drain is at the bottom. However, the option is also there to add an electrical drain which operates on a timer or other electrical signals. The manual drain needs to be checked and manually drained on a regular basis. Physically need to open the drain at the bottom, whereas the automatic drain has a float that opens the drain valve whenever the condensate reaches a certain level inside the filter bowl. But remember, that even if you've got the automatic drain, the drain unit still needs to be checked on a regular basis because particles can cause the automatic drain mechanism to get stuck, which can result in constant blowout of compressed air and a huge waste of energy and money. Please also take care as to where the drain water is going. For example, that if it's not drained into the inside of a panel or on top of instruments, rather direct the water away with a piece of tubing. Now, depending on the yes, Russell.
Sorry to interject. Just an interesting observation from a technical perspective. Very often we quote customers both options, both manual drain and automatic drain. And of course, there is a price variation between the two. But when you consider the fact that I know that the intention is always good, but in practice, people don't on a regular basis maintain these devices. Do you not think that automatic drain should almost be the standard default option?
Yeah, Russell, sorry, just repeat your question there. I apologize, I was just talking to someone here.
Not a problem. No, I said very often we ask to quote on both options from the sales perspective. Yes. So for both the mechanical, the manual drain and the automatic drain. But we know from experience that a lot of people have the very best intentions at heart, and so they will have, or they do have a regular service plan or maintenance plan in place, but invariably it isn't maintained like that. So don't you think that by default, automatic drain should almost be the standard option?
Yeah, Russell, I completely agree with you because yes, you do not need daily maintenance for the automatic drain. But as I mentioned, it could you could fall into the trap of thinking that my automatic drain is draining and it's left outside of the building, and then you do get a piece of rust that gets stuck into that mechanism. So yes, it is the best option if it's high up against the air onto the wall, or it's not easily reachable. That is definitely the best option. But extra care should be taken not to be complacent and think that the unit will automatically drain. So it is a good option, but there is some a bad side to that as well. But yeah.
So bottom line, air filtration, the cleaning of air is a regular requirement. You can't put it in and forget about it. I mean, that's the essence of what you're saying, correct?
Definitely. I think that is one place, and we will see that a little bit later as well, where one can save a lot of energy, but it's one of the places where you can waste a lot of energy as well if it is not maintained. And it can cost you a lot of money, but with a little bit of input investment, it can save you a lot of money as well. But you need to keep a tab on it. It's like your car. I mean, you can't just drive your car forever. The better and the more regularly you replace your filters, the better performance you will get out of that.
Excellent, very valid point. Thank you very much, Hannes.
Okay, guys, so depending on the application, there are different filter types, and depending on the class of air required, the filtration will be done up to a particular grade of filtration. Now, firstly, we get water or cyclone type separators. This unit has no filter elements, but only make use of the baffle structure, as we explained earlier, to swirl the air around the inside of the unit. And as I explained previously, due to the centrifugal force, the water and oil is separated from the air. These types of water separators could get rid of up to 99% of water and oil, but please remember that it cannot extract vapor, and the dew point temperature can still be quite high if the air is warm. Should the air then cool down later on, the vapor will condensate once again, and you will have water in your line again. So that is why it's so important to get the air temperature down as soon as possible after the compressor, so that you can get rid of all the water in the system. Then we also get pre-filters. They are available from 40 to 5 micron, and it's used to get rid of the bigger particles and to prepare the air for a higher grade of filtration. Now, these filter elements also has a similar cyclone baffle structure to get rid of any water and oil that might still be present in the air. Generally, good quality plant air will be filtered up to 5 microns. Then we get our microfilters with a grade of filtration from 1 to 0.01 micron. They are only used if a higher air purity class is required for specialized and precision instruments and equipment. And then we've got our active carbon and our sterile or HEPA filters, also called it high efficiency particulate air filters, which are also available. Now, active carbon is used to get rid of odors and smells, especially for applications where the air could get into contact with food or with food packaging, where the HEPA or the sterile filters are readily used in airplanes, laboratories, hospitals, and sterile rooms to combat the spread of polluted air. And these are probably the filters that we heard are eating up the coronavirus as well. The differential pressure indicators are available on certain filter units, especially our microfilters. This provides visual indication of the differential pressure over the filter. The higher differential pressure, the more blocked the filter element is. If there's no visual indication for the condition of your filter elements available, then as we discussed previously as well, scheduled replacements are necessary for your filter elements on a regular basis or after failure of one of your main upstream filters. So let's have a look at the next component in our service unit, which would be the regulator. Question is always, what is the correct pressure for my system? The answer is quite simple. The minimum pressure to operate the system smoothly. That now being said, for example, if 5 bar is the required pressure to operate your system effectively, do not operate the equipment at 8 bar. Yes, you could have 8 bar up until the regulator, but do not operate your actuators at 8 bar. In our energy saving course, it's quite interesting to see exactly how much energy and money is wasted by operating an actuator at a higher pressure than what is necessary. Now, this is by far the easiest and cheapest way to save money. It's just to check what your operation pressure should be and set your pressure according to that. If we look at the construction of the regulator, the operation is quite interesting. Russell, can you just indicate if you can see my cursor on the screen, please?
I beg your pardon, sorry, I can see it, yes.
Okay, fantastic. Now the white area above the diaphragm is atmospheric pressure. This is where the adjustment spring, as you can see, is pushing down from the top of the diaphragm. There you can see the diaphragm as well. At the bottom of the diaphragm is the pressure after regulation, which is also the output and the line pressure. You will see that is connected and it pushes up onto the diaphragm. Now the line pressure is pushing from the bottom of the diaphragm against the force of the adjustment spring. So the spring force is pushing down and the line pressure is pushing up on the diaphragm. Now as the air is used down the line, the pressure at the bottom of the diaphragm decreases and the diaphragm is pushed down by the spring. This opens the plug. There you can see the plug that is fixed to the plunger for the supply pressure to be let through. Now the outlet pressure increases enough as the plug opens to push the diaphragm against the spring and close the supply, and the pressure is restored to the preset value. There's also an option. I'm going to show you an animation of this just now, just to explain this better. I just want to mention that there's also option for a two-way regulator or a three-way regulator. Now, a three-way regulator is built that, meaning that if there's a buildup in pressure down the line on the output side of the line, for whatever reason, then it will exhaust through the regulator and your set pressure will be kept. All right, so I'm just going to show you a quick animation. As we can see, all right, there's the diaphragm. It's being pushed down by the spring. If we open up the supply pressure, it pushes up against the diaphragm. The diaphragm closes this little port over here, and we are at our set line pressure. When we open this valve, the air will be used, and the diaphragm will be pushed down by the spring. And as the diaphragm is pushed down, it will open this port again, which will enable supply pressure to come into the regulator. As the valve is closed, the line pressure increases and it pushes up against the spring again to close this little port for the supply pressure. If we then turn down the knob and we increase the tension of the spring, then there's more pressure needed from the line pressure to close to push against the diaphragm and to close this little plug, and therefore we get a higher pressure. You can see we've got 6 bar over there now. I just want to show you again. So there, the pressure is set at 4 bar. Our incoming pressure is at 7 bar, line pressure at 4 bar. If we use it, the pressure drops. But when we close it, then the pressure goes back to 4 bar. As we increase the pressure, the line pressure increases to 6 bar, and that is where it closes the little supply port. Okay. There you can see the atmospheric pressure, the line pressure, the surface area for the diaphragm, and the little seat. Now, it's also possible to adjust the pressure remotely with an analog signal from a PLC. You can see there's a set signal and a pressure signal output. This means that the pressure can be adjusted according to the process and at a variable set point. With pressure feedback, it also ensures a closed loop system, which is a lot safer if it's critical. Let's have a look at the last component of our simple service unit, the lubricator. Now, there's also the question, should I use a lubricator? Now, our advice is not to use a lubricator if you have not used one in your system before, and if you're running at normal temperatures and not extremely fast applications. The pneumatic valves and actuators are lubricated during manufacturing, and this lubrication should be able to last for the lifetime of the component, given the air is at a decent quality and the grease is not washed out by too much water and oil in the system. However, like I said, if you have lubricated your system before, you need to keep it lubricated and ensure that your lubricators are kept full, because a lubrication oil would have washed out any grease in your components. Now, here's a system of a service unit with an additional on-off valve, always a safety measure, good practice to install an on-off valve before your service unit, as well as a branching module before the lubricator. So we've got our on-off valve, we've got our regulator, we've got our filter unit, there's a branching module, and there's our lubricator. The branching module is typically there to tap off instrument air before the air gets lubricated. I would like to quickly explain what we mean by air classes, as it's quite important to understand, especially when it comes to more specialized equipment and instruments. When we refer to the air classes, we classify the air according to ISO 8573-1 of 2010. Now, the first column you will see there will be the class rating, which would refer to the into the solids as well as the water and the oil from 0 up to 9. The second column indicates the solids, and the lower the class, obviously, the lower the class number, the less and smaller the solids would be. The third column indicates the water content, and the lower the number, the drier the air. And the last column indicates the oil content. So if we look at an example of a microfilter with 0.01 micron filtration, you will see it over there. You will see that it needs a supply air class of 684. So that is the supply air, the class of the supply air. And it has an output class rating of 172. So after it went through this filter, it would have a class rating of 172. Now, this means that for the supply air of class 684, the solids should be at class 6. So you can see there, the water content should be at class 8. And the oil content should be at class 4. That's the supply air. If we look at the output air class, the solids having class 1, so it would have filtrated all solids up to class 1, water content at class 7, see it there, and the oil content at class 2. So please take care of manufacturers' recommendations to ensure that your air class is correct for a specific instrument or component. Now, what have we learned about proper air preparation? Keep your air clean and dry by using the correct equipment. This will prevent faults in pneumatic systems, increase the service life of machines and components, increase process reliability, and in the end, save you a lot of money. Now, the next topic I would like to touch on is actuators for process valves. And every controlling element in a plant has an actuator. Actuators are classified according to the type of energy used, what it is moving, the type of construction, and according to the type of movement, whether it's linear, rotary, or multi-turn. Now, if you consider all these combinations, you would agree that it results in a huge variety of available actuators. Today, I will focus on the control of pneumatic actuators. And the control elements that we will focus on are valves and control for single acting actuators, the valves and control for double acting actuators, and the flow or speed control for actuators. Let's first have a look at the single acting linear actuator. The single acting or spring return actuator is used if a fail-safe position is critical, with air moving the actuator in one direction and a mechanical spring moving the cylinder back to its normal position, even on air failure. You can see there's a spring to extend and a spring to retract, depending on the position of the spring. But therefore, only one connection is required, the air connection, because the spring is pushing the actuator back or forward to the fail-safe position. As I mentioned, different linear spring acting, single acting cylinders are available depending on the application that you need. Similar to the linear actuators, rotary actuators are also available in a single acting or spring return version for process valves. Now, this is the inside of one of our geared unit rotary actuators. Now, for rotary actuators, the springs are not moved inside the actuator, as in the case of the linear actuator. You will see in the linear actuator, the spring is physically either at the back of the piston or at the front of the piston. Whereas with rotary actuators, the springs are not moved, they stay where they are. The fail-safe position is in fact determined by the way that the actuator and the process valve is assembled. So that is being either in a normally open or in a normally closed position when the actuator is in its default position. Now, the following animation that I will show you will describe the valve that is necessary to operate a single acting cylinder. Okay, if you can see the animation over there, the valve is opened and the air is let into the cylinder. So the piston extends, but to make the piston retract, the valve is closed. You can see the valve is closed now, but the cylinder does not retract as the air is trapped between the cylinder and the valve. So to make the piston retract, we need to add an additional valve to be able to exhaust that trapped air to atmosphere. So if we open that valve, the air is exhausted to atmosphere and the cylinder is retracted. Now, if we have a look at that with a valve or the valve symbol, you will see in the beginning the air is blocked off from the supply. If we move the valve over, port 1 and 2 is connected, the cylinder moves forward. When we switch the valve again, port 2 and 3 is connected and the air is exhausted to atmosphere. Now, this is also the symbol for a 3 two-way valve, normally closed 3 two-way valve, and I will explain a little bit later exactly how we get to that. Now, looking at the animation of the actual valve body, I'm just going to put up another animation for you guys. All right, so there's the actual valve body. By manually moving the spool, port 1 and 2 are connected. So we're moving the spool of the valve and we connect port 1 and 2. Pressurized air goes into the cylinder and the piston rod moves forward. When the spool is released, we've got a mechanical spring pushing the spool to its default position. and that opens up port 2 to port 3, which will then enable air to exhaust to atmosphere. So this is the physical operation of a valve inside. We can also see the operation of the symbol over there. So pushing it, port 1 to port 2, moving forward, releasing port 2 to port 3 with a spring of the single acting actuator pushing the air out to atmosphere. If we now connect a linear actuator, there's our linear actuator, to a process valve like the knife gate valve in the picture. The process valve can be actuated by the linear actuator, moving forward and backwards, and we have an actuator valve configuration as you will find it in your plant. Okay, so that was quick, but moving up to the next topic, symbols and labeling of pneumatic equipment. Let's now have a quick look. So in order to understand the naming conventions of the directional control valves, let's look at the following drawings. So if we look at the valve that's used for the single acting actuator, you will remember it from the previous slides. This valve has a closed and an open position. Therefore, it's got two positions. It needed one connection to the actuator, port number 2, which is called the working port. It needed a supply port for the supply air, port number 1, and it needed an exhaust port, port number 3. Therefore, we need 3 ports or 3 ways of transporting the air. Now, having 3 ports and 2 positions, we would call it a 3 two-way valve. The actuation of this specific valve is a single solenoid valve with mechanical spring reset. If we look at the next symbol, ports 2 and 4, there are 2 working ports, ports 2 and 4. So this valve is used for a double acting actuator, where we need to connect a port to the back of the cylinder as well as a port to the front of the cylinder. We've got one supply port, port 1, and we've got 2 exhaust ports, ports 3 and 5. Therefore, once again, we've got 5 ports or 5 ways of transporting the air. And if we've got 5 ports and 2 ways, there's a forward or backwards, or depending how you connect it, backwards or forwards. 2 ways, 5 ports. This would be classified as a 5 two-way valve.
Hannes?
Yes, Russell.
Just to confirm, so you mentioned just now that the 5 two-way valve, the last valve you spoke about, would be used for a double acting actuator?
That's correct.
So then the assumption is that the 3 two-way valve then would be used for a single acting actuator. Is that correct?
That's correct, because the single acting actuator only needs one working port to push the cylinder either forward or backwards, where the spring would do the work of pushing it then back to its default position. So that's why we only need one working port for the 3 two-way valve, whereas the 5 two-way valve is used for the double acting actuator, moving the actuator forward as well as backwards by means of air pressure.
Great. And the current valve is a normally closed 3 two-way valve. Do you
That's
describe
right, yes.
at some point in time the normally open version of that?
I'm going to describe that in about 2 or 3 slides, yes.
Excellent. Thank you very much.
All right, fantastic. Now the last symbol gets a little bit more complicated. The valve still has 2 working ports, ports 2 and 4, one supply port, port 1, and exhaust ports 3 and 5. But now it has 3 positions. It's got the center position, it's got the right hand and the left hand side position. So therefore, we call it a 5 three-way valve. Now the center position can be different for different valves depending on the application. This valve specifically is a double solenoid valve with mechanical spring return to center position. Now Russell, here it comes. We can now distinguish between the following valves. For example, a normally closed valve on the left, where the normal position of port 1 is blocked off. That's why it's called normally closed. For the application on the right, a normally open valve is used. You will see that the working port is connected to the supply port in the reset or the normal position. You will also see what the impact is on the cylinder. So in the normally closed, it will not let air through to your actuator, but in the normally open, it will let air through to the actuator, and the actuator will be pressurized the whole time. Once again, these different valves are used depending on the application. So please note, for a 3 two-way valve, the valve is identified according to the box or the position of the valve right next to the spring, if you can see on the symbol there. So this is a normally closed valve because the box right next to the spring is normally closed, and this is a normally open valve because the box right next to the spring is normally open. That is the normal state of the valve then.
Hannes?
Listening, Russell. Yes.
You might want to mention that is where you get the fail to open, fail to close conditions in process automation coming from.
That's correct, yes. Yeah. So fail to open, fail to close in process. Russell, I think if you, I want to get through my presentation quickly because I still have a few slides. Would you like to just put that in the parking lot and we can just discuss that at the end, where you can just elaborate a little bit on that, please?
Will do. Thank you.
Thank you. All right. So similarly, we have the different 5 three-way valves with their mid positions now as the normal position, and they are named by their mid position also. These valves are named according to the working ports, port 2 and 4. So first of all, we've got 5-3 normally closed. You will see ports 2 and 4 are closed. Normally pressurized, ports 2 and 4 are connected to the pressure, and normally exhausted, so ports 2 and 4 are connected to the exhaust ports 3 and 5 in the normal position. Okay, so now that we've got a better understanding about the principle of the valve, let's have a look at the 5 two-way valve for a double acting actuator. I'm just going to get another. Okay, so if we want this cylinder to move forward, we need to open port 1 to port 2 to put pressurized air at the back of the piston rod. But we also need to open port 4 to atmosphere for the air in front of the piston to escape. So we add port 3 and 5. If we open up port 2, then from port 4, it escapes through port 3 to atmosphere. Similarly, if we have to move back, then we need to open port 1 to port 4, connect port 1 and 4, and connect port 2 and 5. So port 1 and 4, pressurized air in the front of the piston, and port 2 and 5, air is exhausted to atmosphere. If we look at the valve symbol, we will see that port 1 and 2 is connected, and port 4 and 3 are connected, exhausting to atmosphere. And if we move over, port 1 and 4 is connected, and port 2 and 5 are connected. Okay, so the same 5 two-way valve would be used for a double-acting rotary actuator. You will see the difference between this picture and the previous picture. The previous picture had springs on the sides here, pushing the piston to the inside. This is a double-acting rotary actuator, so you would need air to push the piston to the inside from both sides. And as you want to actuate it in a different direction, you would put air to the inside of the piston, pushing the pistons outwards and rotating the shaft for the process valve to be actuated. Okay, so now we've covered the valves and their symbols, but let's quickly have a look at the actuator symbols that we've covered. So on the left-hand side, we've got our linear actuators. This is the symbol for the double-acting actuator, your single-acting actuator. Remember, we get a spring to retract what we see here, and we get spring to extend. And at the bottom, we have a double-acting cylinder with integrated position feedback. On the right-hand side, when we get to our process actuators, we've got our quarter turn actuators. So the first one is a double-acting actuator, and on the bottom here is a single-acting actuator with spring to return. You will see the spring there. So on this slide, we can see different controls or actuation methods for the control valves. Remember, the control valve is controlling the actuator, which is in turn controlling the process valve. So there are a few examples of manual actuators, mechanical actuation, electric actuation, and pneumatic actuation. Okay, so we had a look at the importance of having clean and dry air. We had a look at actuators for process valves, which included single and double acting, linear and rotary actuators. We had a look at identification of the symbols for valves, actuators, and pilot valve actuating methods, whether it's manual, mechanical, electrical, or air piloted. Now, this last very important topic is speed regulation for actuators. Now, there are different reasons why speed regulation for actuators are important. For example, water hammer can occur easily if a process valve is not closed in a controlled way. To increase synchronized performance of control loops and to ensure that control sequences are carried out in a timely manner. Please keep in mind that the response time of actuators are dependent on the type and the size of the actuator. Now, the most significant factors to affect actuator operating times speeds are the torque and the force curve of the actuators, comparing with the torque and the force curve of the valve. Actuators are selected according to the torque and the force curve of the valve, and not the other way around, to ensure that the most economic selection for the actuator is made. Air consumption for very large actuators, obviously the limiting factor could be the air supply to the actuator. Then double acting or spring return designs. Spring return actuators require a much higher force or torque because the piston is pushing against the spring force on the inside. So if you've got a constant air supply, a double acting actuator generally will move faster than a single acting because less torque is required to turn that actuator. Springs do not have the same force at the end of its stroke compared to the spring force at full compression. So if you compress a spring, it's got a high force, whereas at the end of its stroke, it doesn't have that high force. So therefore, the speed of a single acting actuator will not be the same at the start of the stroke when the springs are fully compressed compared to the end stroke when the springs are extended. Flow restrictions. Also, whether it is a characteristic of the actuator or an external flow regulator, which is put in place to restrict the speeds on purpose. Often internal channels of the actuator are the smallest in the system and therefore the limiting factor, irrespective of the size of the supply line. So for example, if there's a small little channel inside the actuator of 6 millimeters, it would make no difference whether you've got an 8 or 10 or 12 millimeter supply line. And then also friction within the actuators. There are ways to keep friction inside actuators to a minimum, like keeping your air clean and dry and using the correct process valve for the correct application. Misalignment of those valves can put side forces on the actuator bearings, which could also lead to excessive forces and friction and ultimately failure of the valve or the actuator, or perhaps both. Now, speed regulation should always be done in creating a cushion with the exhaust air and not by throttling the supply air. This is extremely important. If the supply air is throttled, you get what we call a stick-slip effect, with jerky movements and very little control over the speed of the actuator. I'm going to show you an animation just to show how we throttle the airflow on the exhaust side to create a controlled movement. All right, so first the actuator is going to be moved forward without any speed control. You can see that. And it can move backwards freely because we're using a one-way flow control valve. Now you will see here is the little throttle. If we move that in, so we set the throttle, and if we actuate the actuator again, you will see the cushion pushing back on the front of the piston. So at the back, you've got your air pressure, and the front, the restriction of the air is pushing back on the actuator, and that is exactly what we want. If we look at the construction of a one-way flow control valve, we see that port 2 is always connected to the actuator. From port 1 to port 2, the flow control is bypassed. If you can see here, from port 1 to port 2, the flow control is bypassed. But if it comes from port 2 to port 1, it cannot get through there because that's a one-way flow control valve and it has to go through the restriction. So if we look for the air moving into the actuator, it's a free flow, but air moving out of the actuator it has to go through the restriction, and that's where the speed control comes in. If you go in a different direction, in the other direction also, from port 1 to port 2, going past the one-way flow control valve, and if you move from port 2 to port 1, the one-way flow control valve is closed and it has to go past the restriction. Flow control valves can obviously be used on linear as well as rotary actuators for speed control. It is usually preferred to have the throttles on the actuators themselves where possible, or as close to the actuator as possible. But in applications where actuators are hard or impossible to reach, however, the throttles are placed on the exhaust port of the valve. You can see it's placed on the exhaust port. Remember, air is exhausting through ports 3 and 5. So if you throttle port 3 and 5, then you can also get a speed control effect. But remember now, because the whole system is under pressure, from the actuator, through the tubing, through the valve, and only then it gets throttled, leakages are more likely to increase and wear may occur. Also, speed control is not as effective then as when the flow controls are mounted on the actuator itself. Now, guys, thank you. This then concludes a very brief overview with a lot of content of some of the most important aspects when it comes to control of pneumatic actuators. In our process course that we're developing, all these aspects and a lot of practical applications will be covered, as well as a lot of hands-on sizing and selection and practical exercises. You will be unmuted now, Kirsche, if I'm correct, and you're welcome to ask if you have a question on any of the topics that we've covered today.
Hannes, it is Rolf.
Yes, Rolf.
Just one question. When you refer to your flow rates in the air, is that compressed air or is it free air that you refer to?
If you say flow rates of compressed air?
Yes, when you size your filters and your actuators.
Okay, that is compressed air. Yeah, that is the flow rate of compressed air. Let me just go back to that slide quickly. Is that the slide you're referring to, Rolf?
Correct.
Okay, yes, that is the flow range in liters per minute of the compressed air. That is correct, yes.
Another question before I go off. When you have a large diameter or larger diameter of, say, linear actuator, is there a guideline for the size of connection or your air supply? I've experienced some problems in the past where the lines are undersized and you have like a jerking motion because the air compressed in the cylinder builds up, but then when it starts moving, it drops. So you have this variation inside the cylinder.
Yeah, Rolf, that is exactly what we meant with a stick slip effect. So that will also occur when the air supply to your cylinder is not sufficient. So there's a general connection rule of thumb basically for your actuators. Normally it comes with a threaded port on the actuator itself. So it is advisable not to go smaller in your supply line than the port on your actuator. But if you do get a slip stick effect, it is, as we mentioned, advisable to put a flow control on both sides of the cylinder so that you can generate a cushion at the back of the of your piston in order not to get a jerky movement. And then what is happening, you get a jerky movement, the pressure at the back of the piston reduces so much that it cannot overcome the friction. Then it slowly builds up, and when it overcomes the friction between the piston and your body, it jerks forward again, and that is why you've got your stick slip effect. So as soon as you've got a cushion at the back, and that cushion prevents that cylinder to jerk forward, then you get a much smoother movement of your cylinder. But as you mentioned, it might be a situation that you don't have enough air supply. So even if you've got a big diameter tubing going to the actuator, it doesn't necessarily mean that you've got enough air supply to that. So that might be a problem, especially if you run over large distances.
Thank you.
I think if I can interject there, Hannes, I think the rule of thumb is exactly like you describe. If you try and size your air supply according to port size of the actuator itself, that's kind of really the governing factor as a rule of thumb. We got a couple of questions from the audience, Hannes. Can we look at the questions,
Yes,
please?
Yes, please.
Okay. So one of the questions that has come through, is actually from Peter. He's asked to confirm whether there's a distinction between the pneumatic symbol for a quarter turn actuator that's for 90 degrees, and that is now, of course, comparatively to 180 degrees rotation. So bearing in mind some of the actuators for process automation can turn 180 degrees and some 90. Is there a difference in the symbol, the pneumatic schematic?
Russell, will you answer that question for us?
Yeah, okay. I was double checking with you, Peter. There is no distinction as far as I understand. I haven't seen any indication before that it sort of indicates otherwise. So you can take it that it's a one standard symbol for both. All right. Another question, Johannes. Let me just try and read it out to you. For the coupled rate regulators with the filter and lubrication, what is the frequency of filter servicing? And what are the requirements for it to be serviced? Okay, so that's the first part of the question. So how often, I think, is the question, how often must it be serviced?
Yeah, there's not a specific prescription on how often it has to be serviced. The prescription is depending on what the quality of your air is that's going through that filter unit. I know at the coastal regions, especially where there's high humidity, the filter units or the filter elements tend to get softer quicker and get clogged quicker because of the content of the water. So generally at the coastal areas, you will replace your filter elements more often, but you will have to see when that filter unit gets clogged or not. One way to find out is to connect a differential pressure gauge across that filter unit, and let's say after 2 or 3 cycles, you will then find out that after 2 months or 3 months or 6 months or a year, your differential pressure will increase, and that you will then need to replace those filters. So there's no specific indication of when to replace the filter elements or when to service the filter units. It depends completely on the operation, how much air is going through that filter, what the air quality is that's coming through there. So you will have to, it's unfortunately going to be by trial and error. But like I said, one way to determine is to put the differential pressure gauge over the two, over the supply and the output line. And then you will see whenever the differential pressure increases, you will know that your filter is blocked, and it will give you a good indication of how often you'll have to replace that filter element.
So we can summarize it. Essentially, there's no hard and fast rule. Depends on the conditions. That's first and foremost. But there is equipment to measure both flow and pressure across a particular application. So one can quickly determine if there is a lessening of airflow or a decrease in pressure, which of course would provide you or the plant or the machinery, the PLC, an indication that it needs to be changed out. So there is a high level of sophistication that can be implemented for monitoring of air conditions, right?
Yeah, you're 100% correct. We've got little digital pressure gauges which got specifically differential pressure inputs. And as you mentioned, it's very easy to connect that across that the filter and send the signal back to a PLC, which will give you an indication whenever something's wrong.
Okay, magic. I think an important point to make note of is that a lot of instances where air preparation equipment is installed into an application is often forgotten about. It's like a once-off installation, and in very few cases do maintenance departments take the care to go and maintain, replace the filter cartridges, make sure the bowls are working properly, automatic drains are working properly. So just I think a note out to all of our customers and all of our partners out there that it is the one element that can really cause you a lot of grief. That's probably why Hannes spoke so long about it today. It is really, it can cause tremendous downstream problems with premature failure of equipment, and it's very often overlooked. So if there isn't a maintenance procedure in place in your factory, I suggest you guys put one in place. But of course, also bear in mind, we have some very sophisticated equipment that can then provide you these fault finding diagnostics much closer to the point. So you don't necessarily have to go and do physical inspections as often, because the equipment can provide you live update and status updates.
Russell,
Okay.
just on that point, we do have an energy saving service available. So if anybody's interested, they can just contact us. And like I said, we've got energy saving service available that we can do a plant walkthrough, do a little take on what you've got and where you can improve. So we've got that available as well.
Okay. Some further questions here. How long do air hoses last before failure or leak set in? That's from, I think very similar to the previous question.
Yeah, I think
Dennis?
the one of the most important factors here, Russell, is that you have to get the correct hose for the correct application. There are hoses which are specifically for UV resistance if the hose is running at the outside and it's exposed to UV. There are hoses that's particularly hydrolysis resistant if you know that you've got a lot of water in your system, or if the hose is running in a water environment or a very damp environment. There are high pressure hoses. We've got hoses that that even at high temperature still you can still get high pressures from it even at high temperature. So it's pneumatic hosing is not just pneumatic hosing or tubing. It's very specific to the application, and the more accurate you spec your hose, the longer it will last. But once again, depending on the quality of the air, where that hose is running, it's very difficult to say exactly how long a hose will last, pneumatic tubing.
Yeah, I think also, once again, in summary, I think we have a comprehensive tool available to help us select the right type of tubing and fitting and hose for the application. It is application specific, but a small variation in color or material can make a huge difference to the longevity that the particular fitting or tubing provides you. I know that we sell kilometers of tubing for underground applications where there's a lot of exposure to acid. So the list of our tubing called range covers extreme conditions, and but simply said, a very small change can make a massive difference to the longevity of your tubings in the environment.
Yeah, something as small as a color, as you mentioned.
Yeah, exactly. Just scanning through questions here. Here's another question. What is the time frequency for your oil drip feed? So I'm assuming he's referring to the lubricator oil drip feed.
Yeah. The time frequency also depending on what the consumption of your air is. You need to see that there's not an accumulation of oil in your exhausts or in your silencers. So as soon as there's an accumulation in your silencers, you will know that your drip rate is too high. But you can also open up your actuators and just see if it is lubricated. So as soon as it's lubricated, you will know that the frequency is sufficient. Too low is not good, because obviously the actuators will move, and the more it moves, the more air it will use. So once again, trial and error. There's not a set prescription on this is how much, but like I say, very often customers say, oh, let's rather give you too much than too little. And then if that air goes through a valve terminal or something, it can really damage that valve terminal, or make the lifespan of that valve terminal a lot shorter. So trial and error, see that your actuators are lubricated on the inside, but that you don't have a accumulation of oil, especially on your exhaust and your silencers.
It probably flows into the next question or statement. One of our participants said, I heard Festa Zeta handles energy saving services. Kindly share your experience and the scope of such done.
Yeah, Samuel, that is very much a consulting service that we've got. We've got air quality equipment, or we make use of third-party partners for air quality testing. Now, it's quite a comprehensive test, so they will test the air quality in various areas, and then also energy saving. That's where we look at the length of your tubing, if we can move perhaps a valve closer to the actuator, because remember, if you actuate a cylinder, as we saw now, air needs to be exhausted from your actuator through the tubing to your valve. If you move a valve closer to your actuator, then the length of tubing and the amount of air that you need to exhaust is much less. So simple factors like that. Like I mentioned, if you just tune down your pressure and the system is still running smoothly, it saves a lot of air. So yes, I would appreciate if you can just send me an email or email to our contact center, and they will get into contact with me, and I can just give you some more information on that. But it's very interesting, and I think nowadays it is such a relevant topic, energy saving in plants and how we can get the most out of our equipment with the least amount of energy.
One of the statements was made about air measurement, leakage detections and corrections. I give some time for Sky to come online. He knows the system very well if he is available. But essentially, we also have able to test for air leakages in plants. We also have devices to be able to pick up the air leak in a plant or installation. So there's a variety of components that are off the shelf, as well as, of course, services we offer to take a look at air leakage, because, of course, as you understand, leaking air is a massive loss and a very expensive exercise, and you want to try and eradicate all those air leakages as best possible. Sky, are you available to give a quick feedback? I'm making some liberties, taking some assumptions here.
Yes, Russell, can you just specify your exact question again?
Okay, so it wasn't really a question, it just simply said, yeah, air measurement, leakages, detections and corrections. So I'm assuming they're leading to the fact that we can detect air measurements, leakages, detections, and make the necessary corrections.
Okay, look, without more information about the actual question, what is very interesting and will shock most people is that a lot of the research mentions that between 30 and 40% of all compressed air, at least, is wasted through leaks. And if you think about your energy consumption, and if you're throwing 30 or 40% of that energy away, it really is a waste. And we can picture it in our minds for ourselves. If we've got a machine that has pneumatic cylinders on them, or we have a process plant that has quarter turn actuators opening and closing butterfly valves, for example, and that valve opens 4 times a day, and each time we open, we exhaust the volume of that actuator, and that's energy consumption now. Now imagine there's a small leak, and that leak is leaking 24 hours. So that kind of gives you a picture in comparison to the energy used, as in when the compressed air is turning the actuator that possibly opens and or closes 4 times a day, compared to an air leak, which is leaking to atmosphere 24 hours a day. So when it comes to energy saving, there's usually massive opportunities in and around compressed air and maintaining the air leak situation. And how they usually do it is when the equipment is not running, you put a flow meter in line and it detects what flow is flowing, and you can do a calculation back to the running maintenance costs and the electricity costs of the compressor. Or else, while the equipment is running, we have audio equipment, sometimes refer to it as a sniffer, and you run it along all the joins and along the lines and all the connectors, and you can actually detect where the leak is with this little audio amplifier. So maybe that's a bit of a background of interest there, Russell and Hannes.
Hannes, if I may come in here. Rolf.
Yes, Rolf, please.
I'm going back many years where one of the major steel plants actually wanted to order another compressor from me. And I supplied a compressor just to get a call. So while they're going to have a meeting, and I requested we do a plant walk walk through. And your leakages you can detect very much by normal ear because of the pressure. And by the time we finished the survey, I said to the gentleman, I said, please fix all your air leaks. I don't think you need another compressor. And it turned out that he didn't add anything to his plant in the last year, but a lot of these automatic drains and a lot of the connectors were actually leaking air. So yes, just by walking through your plant and listening carefully, you can actually pick up a lot of the noises and a lot of the air losses that can be extremely costly. That's my bit.
Yeah, thank you, Rolf. Yeah, that's very true. Just by what you're mentioning is just by listening and just often common sense, you can detect leakages and make a huge difference to your energy consumption, as Sky also mentioned, which is directly converted to money, and yeah, it could be run up to a huge bill.
Yeah, where I was going with the question to Sky earlier on is we have basic devices, and not just Festa, but companies like Festa, basic devices available off the shelf that monitor air consumption and flow and pressure on a continual basis that can be logged to a PLC. So it can be time stamped and logged to a PLC. So you get an exact indication of what your consumption should be, and as perhaps the desired conditions, like a good installation. And then, of course, based on the benchmark, you get feedback about the consumption. So as soon as you see a deviation, of course, you can take the respective.
Hello.
All right.
Yes.
Seems like we got some background noise. Kirsch,
I think it's someone. I think it's someone who wants to ask a question, Russell. Jacobo, can you hear us? Jacobo, the sound is not very good. If you don't mind, can you perhaps post the question in the chat box? Russell, you mentioned now the components that we've got, the equipment that we've got. In some of our, you can combine in our service unit energy saving units, where it also picks up whenever a machine is not running for a certain amount of time and it blocks off the air supply to that machine. So if should there be small leakages in a machine, which there probably are, especially if it's a big system, and you're not running it for a while, it blocks off that that air, so that there's not the risk of having that small leakages. So that's also components that we've got available off the shelf.
That's quite right. Look, yeah, I think, Hannes, in your defense today, I think a lot of time was spent on air preparation, but we believe, and this is not myself, just of course, Rolf will have the same sentiments as well, that, as you said, the air is the most important element of the pneumatic circuit itself. And if it isn't taken care of properly, you're going to pick up issues downstream. We can recount countless examples whereby a simple air preparation preventative action has saved thousands of rands, if not hundreds of thousands of rands, by simply putting in the right air preparation equipment, or by rerouting the piping properly, or by taking small, in some cases, very cost-effective solutions just to avoid the unwanted water coming through downstream, unnecessary compressor oil, condensation, particles, and so forth. So there's a lot we can do in this space, and often it's underrated by the customer. As I said, what very often happens, installations are put in and it's forgotten about. I think collectively we can recount lots of stories where we brought into factory conditions, we've been told about premature failure or something, but when we take a look at the unit prior to the component, the actuator, you open up the filter bowl and there comes out gushing either particles or powder or cement or sand or water, whatever it may be. So it really is something which I think we can really emphasize and overemphasize again and again.
Yeah, and Russell, if you take the what it costs to replace a filter element for the smaller, or your general quarter turn or quarter inch or half inch, it's I think under $100. for a filter element, where the risk of running that filter element until it blows and damaging very, very expensive equipment, the risk is really high, and you're opening yourself up to a lot of unnecessary expenses.
100%. Little story. We have a customer in Africa who was using, it wasn't actually our particular positioner, but they were going through a couple of them a month. So we introduced a filtration panel because the air, I should say the water was exceptionally aggressive, but the air was particularly bad. And they went from a couple of units per month to nothing in terms of consumption. So it stopped the malfunction or the premature failure of the positioners. So there's a lot of sensitive equipment in the process automation space. I'm thinking about instrumentation measuring equipment. I'm thinking about positioners. I'm thinking about valve terminals that require a better air quality. And as soon as the air quality is sorted out for the application, the equipment just lasts and lasts and lasts. So it's vitally important to bear this in mind in the course to discuss this topic.
Russell, I see there's another question from Rakesh where he says our solenoid valves are being damaged by over lubrication used for cylinders. How can we save solenoid valves? Now, as we mentioned, Rakesh, we've got plant air and we've got instrument air. Now, you will probably use instrument air for your solenoid valves, especially if it is valve terminals, because those valve terminals are, the ports inside of valve terminals often blocks up, especially if there's lubrication involved and it ends up being a sludge together with some of dust particles that can come through. So my two suggestions is having an instrument air line or adding an additional filter before the air goes to your solenoid valves, just to take out some of that lubrication. Now, the microfilters do absorb oil particles that are suspended in the air, whereas the 40 and the 5 microns only get rid of the available oil particles. So my suggestion is either use instrument air for your solenoid valves specifically, separately from cylinders if it's possible, or then put in an additional filter. I don't know if that answers your question. Obviously, it won't work if the solenoid valve is driving that specific cylinder. Then the air has to go through that solenoid valve. Perhaps one should just have a look at the different options for solenoid valves, or just reducing the amount of lubrication that you're using.
Yeah. Hannes, there's a question asked earlier on. I think the person may have left, but let's just tackle it anyway. The question was posed about, I didn't fully understand the question, but he was asking about the difficulty of using the manual drain, and I suppose maybe the frequency of using it, and are there any other options? Now, I know collectively in the team we have a fair amount of experience here. If I can kick it off by saying that often what we used to do is remove the manual drain screw and put in a more robust type of ball valve, or connect it to a very robust type of solenoid valve to purge automatically after a while. So in essence, when you have a vast quantity of water coming through, you can, and maybe the little knurled nut isn't really the right mechanism for you, then you can of course use simple robust solenoid valves to open and close on a time basis. You of course can put a very crude ball valve at the bottom end to open and close it if that sort of suffices for you. But before I open the question to the rest of the team, what I would say is that maybe a water separator, which once again is another product from Festo and companies like us, is maybe the ideal solution. So we have a very robust device meant for taking out excessive quantities of water prior to the filter itself. So if you are getting the situation whereby your filter is becoming quickly full, the cartridge itself or the bowl, then maybe you need to consider a water separator prior to the point. But any tips and points from yourself, Hannes, or from the rest of the team?
Yeah. Once again, Russell, I don't know if Rolf has got something to say, but I'm going to chip in here. Once again, that is why it's so important that you get the air cooled down as quickly as possible, and you can get rid of the available water with something like a water separator or the cyclonic filters, as we've discussed before. So the more water you can get rid of through one of those big bulk filters, the less you have to open and close your smaller filters that is perhaps not as bulky and robust, and not manufactured to open 2 or 3 times a day. But I think your suggestion of putting a like a timer or a timer actuated or electric actuated drain at the bottom of that filter units, so that you don't physically have to open and close, is a good suggestion. Obviously, they've got a lot of problems with water in his plant, and it's something that will keep on happening unless they take additional steps or alternative measures.
I know that the water separator isn't the first thing thought of, but it's very effective for removing bulk water as you propose. So that maybe is the first point of departure. Thereafter, if you still need to drain it on a more regular basis, well, there are some very, very effective and very, very robust solutions that are available.
No, it's quite difficult. It's quite difficult to come up with a solution. So I would suggest that he gets into contact with one of our official partners. If he's not in South Africa, they are quite skilled technically, and I'm sure they will have a look at the bigger picture and will be able to give them very good advice as well for his specific application.
Yeah, noted, without a doubt. I think all these pretty much are about application.
Yeah, if I may just quickly butt in, here's Rolf again.
Yes, Rolf.
People don't realize the amount of air, water in the air. Typically, a 4 kilowatt compressor at sea level with high humidity can actually produce 25 to 30 liters of water every day. So it's critical to make sure that we. I've lost my audio.
No, we can hear you.
For you, Rolf.
Okay, let's try again. Yeah, at sea level, especially where high humidity is, you can accumulate 25 liters of water on a 4 kilowatt compressor per day. And that's just operating it for 6 to 8 hours per day. So it's very critical to get your after cooling and water separation to maximum directly after the compressor before you're going into the air receiver, and also make sure that your air receiver itself has got significant drainage capacity, automatic water traps or whatever is required. And then, yes, always recommend that you have a refrigerant type of dryer or some form of dryer to remove the bulk water. Thanks.
Thank you, Rolf. I think what is important to understand is there's a holistic approach you can need to look at your air line or your air supply. I wouldn't look at it in isolation and say, well, at the particular machine there's lots of water. Let's take a look at the overall setup and try and find a solution for it. So therein, I think, is the invitation. Companies like us can, of course, offer these facilities for you, services for you, whereby we analyze your air requirements and then take a look at your current supply and then make recommendations based on that. And not all of it has to be a very expensive exercise. In some cases, it can be very inexpensive fixes to some serious problems.
Yeah. I'm just reading Rakesh's comments here. He says we're using common air with the FRL, which is the service unit before the solenoid valve. No separate instrumentation air is used. We are using refrigerated dryer with compressor. So if the air is clean and dry, if you're using a refrigerated dryer with a compressor and the air quality is quite good, the only thing I can imagine is that there's a little bit too much lubrication going into the system. But Rakesh, I would really appreciate if you can just once again get into contact with us, or we've got your contact details and we can get into contact with you and just come and have a look at your specific application. I think that is the best thing to do at this stage. Anything else from your side, Russell?
No, I think it's pretty much all the questions we have looked at. I think we're going to close off in 6 minutes from now. I think we did a lot for half an hour afterwards. So maybe what we can suggest is we can actually open up the mics to all audience members, and if they have any questions, they can perhaps pose it to us verbally, and then we can just address it there and then.
Russell, I see Horst is just reminding us of the fail to close and fail to open.
Okay, all right, magic. Well, let's talk about the topic quickly then. So fail to close, fail to open in the process automation world simply means that the actuator, when there is an air failure or electrical failure, needs to either fail, in other words, extend or retract or close or open the valve. So think about a knife gate valve. Fail to close would be that the knife gate valve in its unactuated or at fail position is closed. It's closed against the flow or media itself. But for whatever reason, you also might want to open. So you don't want to bottleneck either downstream, upstream or downstream, and you want the valve to open. Then conversely, you then need to make sure that in the event of an air or a electric failure, that the spring pack inside the actuator causes that valve to open. So I hope that explains the distinction. It really is reliant on the mechanical spring pack in the actuating device, either quarter turn or linear, to cause it to open or close against the media.
Russell, I've just put up a screen on the right-hand side or on that I'm sharing that gives a good example of what is possible with some different valves. So in the first picture, you've got the top row is the single acting actuators. The first one is a single acting 3-way pilot operated fail-safe valve. So as soon as your air or your electricity falls away, you will have a fail-safe condition. At number 2, you will have a stay put on electrical failure. So depending on where the actuator is, as soon as the electrical, as there's an electrical failure, the actuator will stay there. Number 3 is a stay put on air and electrical failure. Now the bottom of the double acting, very much similar, but you can choose what your fail-safe condition is with some configurations of different valves and different actuators. So whether it's fail to open or fail to close or fail to stay put, anything is possible with, especially today with the PLCs, it makes it very easy, but with some clever valve configurations, it's also very easy to accomplish whatever your fail-safe position is.
Yeah, I think it's a very big topic, this, and I think we can a lot discuss on this, and that's actually where the value of your course comes into play. And but if you consider the fact that I spoke about the spring pack inside the actuator to make it fail open or fail close, behind that, of course, you can also use an air receiver to create the same functionality. So in many instances in plants these days, the end user is not wanting to have a mechanical spring pack to cause the device to fail open or fail close, because of course it has inherent risks. So therefore they then use a combination of an air receiver, which is essentially an air volume collector, and a combination of valves in different orientations to cause that device to either open or closed, or even to cycle a couple of times under a fail condition. So with pneumatics, there are many ways to tackle this particular topic. And once again, I think the value in understanding how pneumatic circuitry and so forth works does definitely aid a person in sort of choosing the best solution or scenario for their particular plant or application.
Yeah, no, definitely. And I think
So Russell,
especially
do you
for
understand correctly then that it depends on the process and also the standards in the process? So if, for example, you've got a vessel that's filling up, and if that exit valve then closes, if all electricity and air fails, that vessel is going to overflow or burst or rupture and flood the place. So you've got to make sure that nothing fails to open.
Exactly.
So pneumatics has an inherent ability to do that, whereas electrical actuators don't.
Correct. And Horst, what's interesting, there's as I said, quite a distinct movement, particularly in the mining industry right now, where there's been some nasty incidences where devices have failed, mechanically failed, and caused harm and injury. In fact, some comes to death because of the spring packs inside them. So there is a serious consideration in some places that they consider an air vessel as a charger, or call it a battery, an air battery, to cause that device to either open and close under certain conditions, fail close, fails open conditions, as opposed to a spring pack. So once again, this requires some understanding of how to use different types of valves and different types of configurations to give you the desired result. So you'd imagine that if you had an air failure, you'd have to detect that, and then based upon the detection of the air failure, you'd want the device to either open or close. So you need to open or part of the close a particular valve to give you the desired movements of the actuator that you're driving. So yeah, it's a very interesting topic and certainly very doable in the pneumatic world, but it does require understanding of some basic pneumatic circuitry and components.
Yeah, definitely. It's not only an interesting topic, it could be a life-saving application or decision that you make on how to operate your fail-safe, or what your fail-safe conditions are in your plant, as Horst mentioned. Yeah, so very important as well, other than just interesting.
That's it, no, without a doubt. All right, Hannes, we're now 11:30. We have a couple of participants online still. So what I'd recommend in closing is that if they have any questions, they have our contact details to be sent out from the marketing department. They're of course welcome to contact us directly with more direct or specific questions, of course, applications or plant visits are all in order. But yeah, from our side, thank you very much, Hannes, to what is a very exciting and very insightful presentation from your side. I can't wait for the rollout of the full course. I think we're going to have a massive demand for it in the industry. But certainly, if this is just the signs of things to come, I think we've definitely hit the nail on the head, and I'm looking forward to the next steps for us. Any indication, Hannes, when you intend to bring this to market?
Russell, we're trying to have this 1st of January next year, if all goes well. So we're going to do a few dry runs this year with some employees and get some feedback. So we really want to get that up and running at full speed by the start of next year.
With fluids and licenses for the participants?
We can arrange fluid sim licenses, yes. So Horst, thank you for reminding me. Russell, if you just bear with me 1 second, please, guys, go and have a look on the website, on our Festo website, as well on Didactic website. With the current situation, we do have options of webinars. We've got free webinars, we've got paid webinars, which are not just the e-learning, it's a practical webinar. So you practically work on your own computer, on the equipment, you get a certificate. I'm not going to elaborate too much on that. You're more than welcome to contact any of us to get more information, but it is really unique in its way, and the experience that you get from that webinars. So yeah, please go and have a look. You don't have to stop your training. You can carry on at a very reasonable price. So yeah, Russell, thank you from my side as well for the opportunity. Guys, thank you for everybody attending. Really appreciate your attendance, your questions, your interaction. And yeah, especially air preparation, we saw that it's a very, very critical topic and a big topic. Guys, it's a relatively small investment that you can make for a huge return, or to in order not to have huge expenses later down the line. So please take care of your air preparation. Please contact us if you need any consultation or someone to come and assist you. Energy saving is a big topic, and it's so easy to save energy if you just make a few small changes to your factory. Doesn't even have to cost you money. As you mentioned, just turning down that regulator a little bit can save you a huge amount of money. So Russell, from my side, thank you. Not sure if you've got anything else to say.
Yeah, I think in conclusion, this is the third and also very successful end of a webinar series. What I like, and I think what we appreciate, and the feedback we receive from the customers, is that we've taken a look at the very basics of the process valve itself, and there we have the expertise of AVK, a partner of ours. So when it comes to the raw application where the physical product is going through the valve, we can take a look at that and make sure we make the right recommendations. And then of course, with expertise in automation, we can take a look at what type of actuator is best served or best for your purposes. And then looking at now with the training itself, then obviously how to make sure we upskill and equip your people to understand how they can derive the most benefit from pneumatics and automation control and philosophy. And then other services that came through today were, of course, our energy saving services. So really, between AVK and Festo, I think we have a complete package for you, the customer, to make sure that you get optimum life and production from your equipment. So thank you once again for your attendance and for your participation. It's been great chatting with you guys online, and we look forward to further chats in the future. Thank you so
Thank you,
much.
Russell. Just want to mention one last thing. That process course is a joint collaboration between Festo and AVK. So AVK will handle the process valves. So the selection and the application of the correct process valves, where Festo will then do from the actuation side. So we really cover every aspect of process automation, and yeah, really looking forward to that. Thank you. I'm done now, Russell. I'm not going to say a word further. Thank you.
That's it. Let's close it off. Thank you very much, folks. Thanks for attending. All the best. Keep
Thank you.
safe. Bye-bye.